Hey everyone, welcome to GameSoul. This is very first episode of my From Zero to Minecraft-Style game series built completely with OpenGL. To be honest, this episode doesn't start exactly from zero because I've already prepared some of the basics. In this video, I'll just show you what I've done so far, how I started and what the foundation looks like right now. So let's jump straight into the main function. The project begins with some initial steps, creating the window and basic initialization. Later I'll improve these parts, but for now it does what we need. There is also a debug class being initialized. It's used to quickly render simple objects like a cube in the world, which helps a lot during development. The camera and player also initialized here with basic values like position, just make testing and iteration faster for now. Next, let's go word dot generate. Probably the most important part right now, this function handle chunk generation in a way that keeps the game stable and prevents heavy rendering loads. If you work with GPUs, you already know this. Even with a powerful card, rendering something like 1000 chunk can drop your frame rate like crazy if you don't optimize. So yeah, optimization is everything in voxel games. Voxel graphic looks simple, but without proper optimization, the game becomes completely unplayable. For trend generation, I'm using a header-only library called Fast Noise Light. You can find it easily on GitHub. For now, the word is made of 5 by 8 chunks, each one being 16 blocks. It's not dynamic yet, we'll fix that soon. Each chunk is created through generate chunk, which defines what each block actually is, like stone, dirt or air. Right now it's super simple. Below height 38 is stone, above that is dirt. Later this will get more advanced, but for now it gives us a nice starting point. The chunk read all of its blocks and only create the necessary vertices to send to the GPU. It skips completely hidden blocks, the ones surrounded by others and invisible from very angle. This technique massively reduced vertex count and makes the game actually playable every time something changes in a chunk, like block is added or removed. We call recreate and rebuild that part again. That's basically how word generation works for now. Let's go back to main file. Here we got main loop where all the draw calls happen and updating game logic frame by frame. Let's also take a quick look at the player. Right now the player uses a simple box collider for physics. Honestly, the physics parts worried me a bit. Even the basic collider wasn't easy to get right. I actually used some AI tools, but for now it works pretty well. The main challenge is collision detection and penetration depth. Figure out how far players overlaps with blocks after hitting it. The movement logic is simple but solid. The player checks for blocks in the movement direction and predicts the next position, and if a collision will happen, it moves only up to the contact point. If no collision, it moves freely by its speed. That's how we make sure the player never passes through blocks. For example, if we move 2 units forward but there's a block 1 unit ahead, the player move that 1 unit, stops right there, and next frame stay up. So that's overall structure of the project. For now I think we're in really good place to keep building from here, and in next videos we'll start adding more systems. Thanks for watching and see you in the next one.